All right, let's get started then. So welcome everyone to the HAI Weekly Research Seminar. I'm Percy Liang, Associate Professor of Computer Science at Stanford University. I also direct the Center for Research on Foundation Models, a center born out of HAI. So before we begin, a few logistics. For our Zoom audience, you can use the Zoom chat to message the group, but ask all your questions through Slido. And you can click on the link that is in the chat. And if you don't see it, we can share it again. So later I'll be choosing questions from the Slido after the presentation. Slido has an upvote feature, so upvote the questions you want to ask, which will help me prioritize the questions. So today I'm thrilled to introduce our speaker, Michael Littman. Michael is a professor of computer science at Brown University, studying machine learning and decision-making under uncertainty. He has earned multiple awards for teaching, multiple best paper awards and influential paper awards. He's the co-director of Brown's Humanities-Centered Robotics Initiative and a fellow of AAAI, the Association for Advancement of AI, and the ACM, Association for Computing Machinery. He also has the distinction of singing in the first email attachment that was ever sent. But perhaps more relevant was that he was the chair of the second AI 100 study panel. So for some context, AI 100 convenes a study panel every 5 years to chart the progress of AI from both a technical and societal perspective. And what's unique about AI 100, its longitudinal nature. It started in 2015, and it will probably outlive all of us. So I've gotten a sneak peek at an early draft of the study report when I was still on the AI 100 Standing Committee. Today, I'm really excited to hear about how it all turned out. So let's welcome Michael, and please take it away.
Thanks so much, Percy. All right, I think one way I'll take it away is by sharing my screen and starting some slides. Great. Oh, wait, there's little clapping hands that were just hovering on my screen. So, wow, thank you so much. Well, thanks. Yeah, thanks to to the organizers for inviting me to participate in the research report. The research seminar today, and for Percy for agreeing to introduce me. I was asked like who I wanted to host me, and I went through the list of researchers at Stanford, and I thought, wow, I mean, if Percy's willing to do it, that would be awesome. And I was very glad that he agreed to do so. So yeah, so my name is Michael Littman. I'm a computer science professor at Brown University. And just to get this out of the way, I'm also, since the report came out in 2021, I've joined the National Science Foundation. So I'm now in the organization in the US that funds the most AI research that's not in the Defense Department. And so I'm very involved now in supporting AI researchers nationwide. And but I have to say that I am speaking today not on behalf of the National Science Foundation. So please don't take anything that I say to be their official word on anything. But again, as speaking as a professor and mainly as the study panel chair of the AI 100 report, the second AI 100 report, that's what I really want to share with you today is about the AI 100, about the report, and about the way that this is going to look moving forward. So we decided to entitle our report Gathering Strength, Gathering Storms, and I think you'll see as the talk goes on why I believe that's a very apt name. All right, so Percy said a little bit, and maybe some of you already know about what the AI 100 report is, but let me just refresh that for people who may not be as familiar with it. It's called the 100-Year Study on Artificial Intelligence. And it's a really neat idea. It's a privately funded effort that was launched in fall 2014 with the goal of doing a long-term investigation of artificial intelligence and its influences on things that I can't see because now my screen is blocked. Wait, I can say on people, their communities, and society. So the goal is, so the way that this was envisioned is that this would be a group that would be around for 100 years, and every 5 years there would be a report on like what's up with AI. And I think behind this was the idea that AI is poised to become very important to society and humankind, and it would be really great to try to document how it is evolving over time. And so the idea of putting a report out every 5 years is to say, okay, here's a snapshot, here's where we are right now. The goal of the reports are to envision potential future advances in AI, so to make some predictions about what may unfold, but also to describe the technical and societal challenges and opportunities, things that are happening in the moment, at the day. So the very first report was issued in 2016, and then I was asked to head up the authoring of the report, which would be the second report 5 years later, 2021. I was recruited by the standing committee. So there's multiple organizations that work here. There's the panel that actually put together the text and wrote the report that I'm going to tell you about, but there's an oversight group as well, the standing committee, which incidentally was chaired by Peter Stone and continues to be chaired by Peter Stone from UT Austin, who was the author of the very first report as well. So he has a really nice kind of perspective on what's happened so far. And as Percy mentioned, Percy was on the committee at the time that the report was being written, but people rotate on and off that committee over time to provide sort of guidance and insight about how the AI 100 group should evolve over time. So the standing committee selected a panel to write the report, and I was the chair of that panel. So what can I tell you about the panel itself? Well, for one thing, it was a very diverse group. We wanted to have geographic diversity, that we didn't want this to be a US only kind of report. We wanted to make sure that it covered different academic disciplines. So in addition to computer science, which is maybe traditionally where most of the AI work takes place, nowadays there's a lot more. And you can see the affiliations on the names of the people here: computer science, law, economics, science and technology studies, political science, economics, information technology, so and policy more generally. So it really is, AI covers so much ground. We wanted to make sure we had a committee panel that would be able to represent much about what's going on in AI. And I don't think we want to make a claim that that we covered absolutely everything and no viewpoints were left out, but we tried very, very hard to be as inclusive as we could. So we were given a charge, we were given information, and you can find the actual details of this on the AI 100 website. But just the highlights here is that the standing committee realized that one report had been issued, the 2016 report had been issued. And so the 2021 report would be the very first report for the rest of the 100 years. And they wanted to try to establish some kind of notion of touch points that would be revisited year to year, so that there'd be some continuity through this whole sequence. And I don't know, I envisioned it when I took the role as at some point we'd be able to fill up a bookshelf with volumes, and each volume would represent one of the reports, and there'd be 20 reports. 100 divided by 5 is 20, representing a whole bunch of years. And you look at those years and like, some of those are really big numbers. Like I think that 2023 is kind of a scary big number, but this is going to go on until the 2100s. And that's an exciting thing, and it's rather humbling, and it keeps in the front of your mind this notion that what we're writing is, at least the way I was thinking about it, what we're writing is a kind of time capsule. Like this is what it was like in 2021 to be in our society and thinking about AI. And we had every reason to believe that it's going to be very different in the years to come. But we wanted to capture our moment. We wanted to take that snapshot, bury it in the backyard so that people can come back and look at it and say, oh, wow, look, I can see what's changed. I can see how things have evolved. So so the way that the charge was structured is we were expected to do some reflections, like I was just doing there, a deep dive into a couple different topics, but also a set of standing questions that they created. And the hope was that these standing questions more or less would remain the same for the next 95 years, so that people would be able to do a comparison and say, okay, this is how this was thought about then. This is no longer an issue, but this other thing that wasn't even on their radar then has become an issue now. And so the standing questions kind of form the backbone of the entire report. And I also mentioned a notion that they wanted to make sure that community voices were represented. I think there's a real belief on the standing committee itself that we wanted to make sure that we were speaking for as many people as possible and not just for a narrow subgroup of the AI community. All right, so I'm going to take you through the standing questions and kind of give you a sense of what our snapshot looked like. And it's interesting because, in re-reviewing these slides, I created these slides at the end of the report. A couple years have gone by. AI has become even more visible than it was then, and it's impacting more lives than it was then. But a lot of the fundamental things that we touched on haven't changed that much. So hopefully it won't feel super dated to anyone today. So the very first standing question was a really creative one, which is, what are some examples of pictures that reflect important progress in AI and its influences? And so we ended up choosing basically one picture per standing question that we included in the report. And that gave the report a little bit more flair because, you know, there's pictures illustrating things, but those pictures also were intended to be associated with this standing question. So I'll be showing you these pictures associated with the standing questions that we connected them with in the report. All right, so standing question one, we're gonna revisit that. There's an example from standing question one on the screen now, which is those stained glass berries. But we'll move on to standing question two. So standing question two, what are the most important advances in AI? And again, this is the answer to this, we'd expect this to be changing over time. But the things that we highlighted as of our report included generative adversarial networks, which is the technology that's able to produce the pictures that you see on the screen there. A program called DALL-E. This was before DALL-E 2 existed. DALL-E combines image generation and language modeling so that you could say to it, make a picture of a stained glass window of a blue strawberry, something that to the best of my knowledge, didn't exist in like Google image search. I wasn't able to find such a picture naturally occurring, but the program was able to synthesize these from what it understood about images and words, and was able to create a couple of these that you could legitimately think is a stained glass window of a blue strawberry. As you probably know, one of the battles that people are having with AI technology today is that it doesn't always get the details right. And so you can see in some of these examples, it's a stained glass window of a strawberry on a blue background, which has a lot of the right words, but doesn't quite combine them in the way that was intended by the query. And this was an issue then, and I think it's still an issue today. It's going to continue to be an issue for a while. So generative adversarial networks we highlighted. We also highlighted transformer language models, which if you've not heard of that, but you have heard of ChatGPT, that is the technology that underlies a lot of these amazing programs that can use human language seemingly effortlessly. We also highlighted, and this is, I think, has gotten a lot less visibility, but the notion of making robotic deliveries, especially during the pandemic. So robots going out into the world and delivering packages to people when people weren't really able to interact directly with each other. That was a nice application that we wanted to focus on. And we were very impressed with the penetration of AI systems into hospitals. So I think from the very earliest days of AI, there was an interest in, maybe this technology can help make people healthier. And I think it's been quite a battle. And we're starting to see in the 5-year window that this report covers, we're starting to see real penetration, real projects that are making their way into hospitals and having an impact on real patient care. All right, so standing question 3. What are the most inspiring, open, grand challenge problems? And I have a sense of what the standing committee wanted us to get at with this, but we kind of decided to interpret it as, what are the most important sort of big looming problems that the field should be grappling with? What are the exciting research challenges? And so for us, it came down to making AI generalize well, which again is an issue that is, continues to be at the forefront of the field. Understand causal factors. How do we make it so that these systems don't just understand the patterns in the world, but understand what causes what? And I think, again, that is a very big topic, and it's going to be a big topic in the years to come. And related question of picking up cultural norms. So we know how to train AI systems with machine learning to do things like process images, process language, but really understanding human-human interactions is something that is not been well captured by current systems. The picture that we ended up wanting to associate with this question, this is, you can see a human being, and that human being happens to be Peter Stone, who I mentioned before, the chair of the standing committee, playing soccer against a group of robots. And one of the reasons that this was selected is because what Peter's demonstrating here is human play against robot soccer players as part of the RoboCup challenge. The RoboCup was created as a grand challenge problem for the field, saying that the hope their aspiration was to be able to challenge human champions in soccer by 2050. So a team of robots playing, say, the World Cup champions and having that be a good game and the robots ultimately win. That's what the RoboCup folks set out to do starting in 2000. And so that's actually been grinding away for a while now. I guess we're getting near the halfway point of their challenge. But today, it's still quite far off. And you can see, I mean, Peter's a very good soccer player, but I don't think you have to be a very good soccer player to beat these robots. They're just not that agile yet. And even though we're seeing incredible advances in the abilities of language, of programs to process language, getting around in the real world is hard and remains quite challenging. So steady progress, but the play is still quite weak. Standing question 4 was, how much have we progressed in understanding the key mysteries of human intelligence? Which is a great question. It's one of the questions that really got the field going originally in the 1950s was, wow, if we do this right, these computers can help us understand how people really are, what intelligence really is. And so the conclusion of our team was basically, how much have we progressed? Not very much. Human intelligence is still fairly mysterious to us. We're getting additional insights. The fact that these current AI systems can be so capable is illuminating. But at the same time, I don't think people think that this is how we do it. And the shortcomings of the programs that we have today are, again, sort of revealing of, okay, there's still pieces that we don't understand. One of the things that we wanted to focus on in the report, though, is that the study of network effects is maybe a very promising direction into the future. And this is really at 2 different levels that we talked about. One is that intelligence itself arises from the interaction between brain regions. It's not like there's a little CPU and it's doing all the work. There's lots of things going on in your brain, and it's the interaction of those components that make up what we think of as human intelligence. But also we wanted to focus on the fact that intelligence manifests in cooperation between groups of people. So no single human being is sort of independently, isolatedly intelligent. We really get so much of our capability from how we interact with others and the society that we are born into. And so sort of focusing on those networks effects, we think is going to be a really important step towards better understanding human intelligence. The picture that we ended up using to illustrate this standing question comes from a project to create a game-playing AI for a game called Hanabi. And what I think is particularly exciting and interesting about this particular game is, unlike most of the AI games work that's been happening again since the 1950s, to great effect, amazing play in all sorts of different games. Hanabi is a very different kind of game. It's a purely cooperative game. So this is played with groups of people with cards, and it's basically a distributed solitaire. So, which I guess is a contradiction in terms, right? Solitaire is something you do by yourself, but this is like group solitaire, where you're only allowed to communicate in very careful ways. And when people play this game, they learn to do very sophisticated kind of verbal, but very limited verbal coordination in the group. And you start to learn to see, or you have to really focus on seeing what the game looks like through the eyes of the other people who can't see what you can see. And we just think so this Hanabi AI actually plays quite well. And focusing on those kinds of cooperative games could be a really lovely way of getting more insight into the way that people work together to do intelligent things. All right, standing question 5, what are the prospects for more general artificial intelligence? And so this is kind of a related question in the sense that, again, initially the field of artificial intelligence was motivated by the idea of, hey, let's make a program that basically can think like a person, and then we can have a conversation with it, and we can ask it to do things for us, and we can learn from it. And so this notion of general artificial intelligence, or sometimes human level AI, interestingly, compared to the previous report, feels a little farther off, a little further down the road than we thought it was. I think it's perennially like we're going to work this out in 50 years, but that 50-year window continues to move. But 5 years ago, 5 years before this report was issued, when the first report was issued, there was a lot of excitement. There was a lot of feeling like, wait a second, we might be on the verge of cracking this. And I think the fact that it didn't get cracked, we didn't make significant progress on human level AI in those 5 years, made people realize that, okay, it's still a little bit farther down the road. But there are some technologies that are showing some promise in terms of creating a kind of general intelligence. Unsupervised language models pick up surprisingly large amounts of information about the world just by processing large amounts of text. I think in the time from when the report was issued until now, this has become even more true. It's even more stunning how much these models can learn about the world and about communication. I think at the time there weren't really chatbots built on these large language models, and now that people have shown how you can actually sort of tweak the language models into a conversational mode, and we can chat with them, and they have remarkable things to say, it really is striking. There's more to do in terms of figuring out how these unsupervised language models do what they do and to make them more effective. And I don't think that's the end of the story anyway, because just being an unsupervised model of any kind means you can pick up statistical relationships, but it doesn't tell you what you should do. And so that's not the whole story, but it is actually a really important part of the story. And at least at the time, I feel like this is maybe slightly less true in the couple years since then, is the importance of meta-learning systems to learn how to learn more effectively. So systems that are being trained specifically to improve their learning capability. That shows some promise in terms of generality, the ability to a very general system to tune itself to be able to solve more specific problems. Seems kind of great. There's more effort needs to be put into that as well. The illustration for this particular topic we showed, it would be different today, but what we showed at the time was a large language model, GPT-3 or BERT, showing off some of the stuff that it knows how to do. And so this was just in the context of Google Docs. I typed in the sentence, the chair of the committee working for the AI-based organization creates examples versus the chair of the committee working for the AI-based organization create examples. That long-term dependence, that it should be creates, not create, because the chair is a singular word, even though there's a lot of words in between. Like picking up on that is something that is really challenging, especially in naturally occurring text. And the fact that we all have access to public tools now that can do that can actually process language in that way and make those connections, feels to me like progress. All right, standing question 6. How has public sentiment toward AI evolved, and how should we inform or educate the public? And I think that's, again, I think this is a really great question. I'm really glad that it's a part of this kind of long-term set of standing questions. And that's because public sentiment, I mean, AI and computer science in general has a cyclic nature to it. It becomes very popular and then very unpopular and very popular again. You can see this going up and down, but public sentiment, man, that moves even faster. And so getting a snapshot of how people feel about AI seems like a very valuable thing to do. What we ended up focusing on is that we felt like there was a lot more media coverage than there used to be about AI. It's much more part of the public conversation, but often media coverage exaggerates positives and negatives of AI, and that's it's a natural thing that happens when you're trying to get attention to your story, is to make this the best thing ever or the worst thing ever. But I think it really harms the public conversation not to have a more balanced view and not a more like, yeah, both of these things can be true at the same time kind of perspective. One of the things that the journalists had done during the 5-year period covered by the report is raising public awareness of legitimate concerns, issues about bias, about lack of transparency in the models and how they perform, and accountability. So when they do questionable things, who gets held responsible for that? Who do we call out? Who do we say you need to fix this? And I think that was not so much in the discussion prior to our report, or prior to the 5 years before our report. And I think it's great. I think it's really important that we start to have these conversations as the systems are impacting people's lives more. It becomes even more relevant to talk about, to have everybody involved in the conversation about what are these systems, what are they doing, is that okay? We really need to do that. And so we focused in the report on researchers and practitioners needing to engage in that conversation so that it doesn't become untethered from the reality of the technology. And but at the same time, to engage in it because issues are being raised that need to be grappled with at all levels of the research process. So an example of that is, here's a photograph of a person that does not exist. That's not a real person. That is a hallucination of a person created by a generative adversarial network. And it's amazing. It's incredible that you can get these sort of photo quality images of human faces that are not human. And that creates a lot of excitement, but also concerns. How can this be used to say manipulate people, to make people believe that something's happening that's not really happening, or whatnot? And yeah, this continues to be an issue. Today's New York Times had a pointer to an article on fake news reports that fake talking heads, like fake news reporters, are delivering reports, which they could have just asked a person to do it, but it's even cheaper to just type in the script and then have it look like you have an actual person complaining. Well, it was complaining about the U.S. It was anti-U.S. propaganda, but it was generated using, I don't think it was a GAN, but sort of next generation image generation technology that was, again, being used to manipulate people. And so this is something that really was on our radar, and we'll get to even more, I think, in a future standing question. So let me move on. Yeah. So, all right, so standing question 7, how should governments act to ensure that AI is developed and used responsibly? So I think this is also an important question, though I think it was more acute maybe around the time of the first report, when AI was clearly starting to have some real world impact and governments appeared to be flat-footed about it. I think, well, okay, so now the fact that I'm in government makes me feel like, oh yeah, well, government, we're on it. But nonetheless, it's a really important question, something that we should engage with. So at the time, anyway, many countries are creating AI initiatives and specifically designing them to try to maximize benefits and minimize harms. So there was kind of, again, a recognition that there's a double-edged sword to this technology. Again, related to the title of our report, which was the Gathering Strength, Gathering Storm. Is that the right phrase? Gathering Strength, Gathering Storms. Yes, that's what we called it. Which again is this kind of two, like it's a force, and it's a force for good, and it's a force for bad, and we need to navigate that. So the fact that governments are starting to recognize that and try to put mechanisms in place to maximize benefits and minimize harms, that seems like a really beneficial shift. The level of sophistication amongst policymakers has gone up significantly. And again, I would note, this was written before I joined the government and became, I'm not a policymaker, but I'm interacting with them. This was not a statement to say, look, I'm a sophisticated person, I'm involved now. There was evidence that this was starting to happen, and there was an interest in government circles to involve more practitioners in various ways. One of the things that we called out is that we felt that governments need evidence-based processes to innovate and keep pace with the developments in AI and automation. We didn't want, I think the feeling was some amount of oversight is actually probably needed and probably important, but we didn't want it to be too heavy-handed. We wanted to really encourage governments to, when they put processes in place, that they have some reason to believe that it's going to have the right effect on the field. So one of the topics that, well, again, we highlighted it with the picture here. This is a photograph of me and one of my former PhD students, Bethany Leffler Edmonds. And I just, you can see on the side there, it has, this is in Google Photos. So I just uploaded this picture to Google Photos, and it said, hey, that's Michael Littman and Bethany Leffler. And that was really cool. It's really great, because that means now I can search my images and I can look for pictures of Bethany in my images. And that's been really valuable to me. But that same technology, you run that technology on a large scale in a public place, and suddenly you're surveilling everyone. And I think there's very legitimate reasons to be concerned about the use of that kind of power. And around the time that we were working on our report, certainly within the window that our report covered, many governments were starting to realize, okay, people are reacting badly to this. This is something that we really need to pull back on. And lots of companies either discontinued or paused their facial recognition work. And there's just sort of a lot more rules in place now for what's an appropriate use of this technology. And so that's something that will continue to play out, not just in facial recognition, but in other kinds of public-facing uses of AI. All right, so we had standing question 8. What should the roles of academia and industry be, respectively, in the development and deployment of AI technologies and the study of impacts of AI? So this continues to be an issue that's very much on people's minds, that a lot of the very visible and in many ways groundbreaking applications of AI are coming out of companies. And so the academic community, which in principle is focused on the public good, sharing information, sharing understanding, putting that out into that world so that people can take advantage of it, are arguably behind the curve, or at least that's a concern, is that the academic community is unable to do the things that the big companies are doing. And so with these cutting edge developments happening in industry, we want to make sure that the issues about what to study are not completely under the control of industry, that there's sort of public input into that. And the way that knowledge is disseminated should be also something that's up to the public and not up to private companies. And this balance is continuing to play out. People are trying to work it through. It's just we maybe not so strongly. We ended on, well, it's very important that we keep an eye on this. Like, this is not a resolved issue. We didn't think it was something that required panic at this point, but we thought that it would be very important to keep track of it. The corresponding image that we have here is for a handful of the most prominent AI machine learning conferences, what fraction of the papers that are being published have as their authors people from companies as opposed to people purely from universities. That's been going up. Partly it's because lots of academics actually have dual citizenship, like they're partly in companies and they're partly in academia. And partly, there's labs that are investing a lot of money just purely on the company side to move the technology forward, which is a good thing, right? It's great that there's these sort of private contributions to the research field, and that they end up publishing their papers in public venues so that other people can benefit from them. But if the balance gets sufficiently out of whack, that's something that we need to understand the implications of. And so I think that's the main thing that we ended up focusing on in our answer. All right, standing question 9. I should have told you how many of these there were in advance, right? So you can kind of pace your attention. There's going to be what? It's like 12 and 2, maybe 12 total. Somewhere between 12 and 14. We're going to get there. We're more than halfway done. All right. Question 9 is, what are the most promising opportunities for AI? So, given what we know now, what should we be able to see on the horizon as something that might be worth paying attention to? And so what we focused on was, for various practical and intellectual reasons, that the field should focus on ways that AI technology can be better integrated to work with people effectively. And maybe that's sort of a motherhood and apple pie kind of statement, but the more that we see these AI systems being deployed in the world, the more that this kind of human AI interaction becomes something that is central to the way that the systems should be built and the way that they're designed, the way that they're deployed. And so we thought the most promising opportunities were in better understanding that human AI interaction. I don't know, maybe somewhat presciently, we focused in our image for this one was on transformers and large language models, which again, at the time, were not really being used as a kind of interaction vehicle, but now very much are. And you can see, dozens of articles every single day talking about the impacts that ChatGPT as a kind of interaction technology is having on education, on industry segments like real estate, falsified disinformation campaigns. Like this is a really powerful thing, and people are trying to focus on, well, how do we make this so that it really is helpful and is not, for example, just letting students cheat and putting people out of work. So Yeah, I mean, it's sort of funny to look back. So this is the output of I think it was GPT-3. No, sorry, not Chat, just GPT-3 at the time. Little Tykes LTX battery operated tricycle. I think we asked it to just make up well, we didn't say make up. Write a description of a product. And of course, as these language models often do, it just hallucinated one and then described it actually fairly well. He's been dreaming about his first bike for a while, and now he can hop on and ride around with friends and siblings alike on this bright red Little Tykes LTX battery-operated tricycle. It features an adjustable seat, a footrest, and a chain guard, so he'll stay safe while riding. Battery-operated, it requires 2 AA batteries, not included. This is a toy for children 3 years and older, and seemed to be gratuitously gendered. Like the description focused in on a sort of a male child for no reason that seemed consistent with the description itself. So I don't know, you can, again, it's sort of a snapshot of what was going on at the time. I don't think we're very far past that point now, but certainly ChatGPT has shown various ways of putting up guardrails to generate text that's, a little bit less fraught. We thought that things like automatic summaries of large literatures might be a really beneficial way of using this technology by helping people work more effectively on broad cross-disciplinary questions. I still think that. I think that's still a reasonable direction that things can go. And now that, again, things like ChatGPT are publicly accessible, we're starting to see the creativity of the world, like of people all over the place saying, oh, well, this is how I could use this to do something beneficial. So it's, it's pretty exciting. And again, the focusing on how to make that interaction work effectively, I think is very, very important. All right, standing question 10, what are the most pressing dangers of AI? So what are we nervous about? So of course, we mentioned AI helping to turbocharge the spread of disinformation, as I mentioned before, but also that AI systems are often designed in a way that makes them cater to the majority. And this presents significant risks to members of underrepresented groups. So one thing that was very much on people's mind at the time of this report was a really interesting example called Pulse, where you could give it a low resolution picture of a person's face, and it would say, oh, here's a high resolution picture, like a photograph, that would be consistent with that image. And so an example that went around Twitter and generated a lot of consternation, among other things, is this low resolution picture of former US President Barack Obama, that the system, when it kind of hallucinated a high resolution version that would produce that exact low resolution image, it made him into a white guy. And it wasn't, this is very consistent. You could give it all sorts of people who were not kind of the majority class in various ways, and it would always shift them kind of towards this middle ground. And so the system got a lot of criticism for that, for using GAN technology in a way that was consistently generating images with features that appeared ethnically white, regardless of the selected input image. It's still, I don't think this is a solved problem at this point. I think that a lot of people are still concerned about how to make these systems just behave more reasonably. And so this was for many people, this was a great example that kind of got into their consciousness. And that was one of the things that we were concerned about. All right, another kind of concern is around socioeconomic relationships. Question 11, how has AI impacted these socioeconomic relationships? And it's not hard to find articles where people say, the sky is falling, that the fact that these systems are so capable means either that we've already lost our job, or that we're about to. And that really does generate a lot of concern. We had an economist on our panel who looked at this in a fair amount of depth. And we concluded that, at least at the moment, this is a real possibility. This is something that we should in fact be concerned about and should be closely watched, but that to date, that the rises in inequality and unemployment that we see in the economic numbers do not appear to be due to the spread of AI technology. So there's definitely issues about unemployment. There's definitely issues about inequality, very significant issues. But to the extent that they're understood at all, there's no reason to think that AI is what's causing this. Could it in the future? Sure. And I think it's really important that when a powerful AI technology is made available, that we think through, well, what happens to the people whose livelihoods are impacted by this? Is there a way that we can give them kind of a soft off-ramp retraining, that sort of thing? We didn't argue in favor of we should stop progress. That we do think that these things do benefit people as a whole, but we have to pay attention to the individuals who are impacted most directly. So the image that we showed here is kind of a striking image of some economic numbers. Employment as a fraction of the population, it reached a 20-year high right before the pandemic. And so to the extent that AI was developing and spreading during that period, you just don't see it in these kinds of unemployment numbers. So we're certainly not seeing large scale impact. All right, standing question 12. This is the last of the standing questions. And this is kind of almost a more philosophical, speculative kind of question. Does it appear that building in how we think works as an engineering strategy in the long run? So the idea being that there are not so many camps in the field of artificial intelligence. I guess there is to some extent, but you could imagine a camp that says, look, what we need to focus on is understanding what exactly the modules in the human brain are, making code modules that do those same things, connect them up in the same way, and then, in that way we'll get something that can actually think. And so we were asked to speculate, well, what do you think about that? Do you think that's the way that we're going to be able to achieve more intelligent systems? And we ended up framing the question as, well, okay, there's really two fundamental approaches to AI. We can build things in, or we can learn them, right? So we can actually have people create an architecture, like an actual software architecture, and then fill it in, or we could have a sort of a giant set of parameters and then push lots of data through it and have it tune itself to become, the system that it is. And for what it's worth, the built-in mechanisms kind of dominated the field for at least the first half of the history of the field. And in recent days, learning-based systems have definitely dominated the conversation. What we said in the report is that the pendulum has, that it has swung to learning systems as being the most influential, but we think we're seeing the beginning of an end to that trend, sort of end of peak learning, and a move towards more hybrid design. So some amount of building stuff in, some amount of tuning things using learning, and systems that kind of leverage both of those to get the best of both worlds. That's certainly where my head is on this stuff, and that was what the panel felt as well. One thing that I would like to point out, how am I doing on time? I think probably okay. Or am I? I think that clock is way off. Yeah, that clock is way off. The clock says it's 45 minutes from now. All right. Okay, that's good to know. So let me not elaborate too much on what I was about to say, but hey, Percy, can you see the Slack warning popped up on the screen?
Yes, I think that's on your
Bummer.
computer.
Yeah, this is a thing that has afflicted me. I think maybe we're back. All right. So let me just explain this example and then and start trying to wrap things up. So, I do believe that that there's strengths in both approaches, and that if we really want robust, helpful systems in the world, that we're going to need to draw on both of these. And a nice example that I saw, because I have a background in software for solving crossword puzzles, is that during the window of our report, a system called Dr. Phil came about that leverages both sort of classical AI search to do constraint satisfaction and generic deep learning approaches to do language processing to actually solve crossword puzzles at human champion levels. And so it actually beat all the participants in the 2021 the American Crossword Puzzle Championship. And that was very exciting. So again, I feel like it's by combining these kind of statistical approaches with more kind of logical symbolic reasoning that they were able to do as well as they did. Neither of those alone would have been able to do this. All right. So one of the things that the standing committee asked us to do is, in addition to the 12 standing questions that we're going to hopefully persist from year to year, is that during the period of covered by our report, the AI 100 group supported 2 workshops specifically look at issues that were of interest to the broader community. So people were given an opportunity to propose topics and then run a workshop. 2 were chosen, and those workshops were then run. The representatives from those workshops were on the panel with me, and then kind of wrote up in the context of almost another kind of question, like almost another standing question, but specific to the topic that covered by their workshop. And so these we imagine would be swapped out from year to year. So hopefully in the next AI 100 report, there'll be something like this, but on topics different from what we covered. But our first workshop question was, how are AI-driven predictions made in high-stakes public contexts? And what social, organizational, and practical considerations must policymakers consider in their implementation and governance? So maybe that was a more complicated way to say something that I think is clearly important, which is, as we're putting AI systems into practice and they're making predictions, they're doing what machine learning models do, but in a high stakes public context, how should we be thinking about this? What's the best practices for this? And so we acknowledge that it's important to design AI solutions to real world problems by working closely with the stakeholders. So this is something that the field has not done great over the years, but I think people are starting to really recognize as being important. The notion that you don't just, hey, look, you've got a problem, and then run off, solve their problem, then bring them back to the solution and expect them to be super happy with you. You really need to involve the people being impacted at every step in the design process. And that's sort of a natural best practices, but I think, is worth repeating, is worth saying out loud. If a problem is, so one of the things that I think is worth mentioning is that if a problem is complex enough that we need AI to help us solve it, then it's complex enough that AI alone is not going to be able to solve it, that we actually have to involve the impacted people as part of the process. And recently, just a couple of weeks ago, again, this is something that I know because of my new role, is that the National Institute for Standards and Technology released their AI risk management framework, where they kind of present a best practices for here's how to deploy an AI system and keep an eye on it so that it doesn't cause problems, and that you learn about the problems as quickly as possible and can solve them smoothly as you can. That it really lines up very nicely with what we were thinking as well a couple years earlier. The image that we highlighted is the notion of a data sheet, and things like model cards, which are documentations of the inputs and outputs of a machine learning system. So it's not just like, hey, this machine learning system does this thing, maybe you could use it, but to really say, this is what this machine learning system does. This is where the data came from. This is what the data represents. That needs to be well understood and well interpreted so that it's not used inappropriately downstream. If it's not documented, it becomes very difficult to know whether you're using it, off-label, using it different from the way that it was intended and different than the way that you'd expect it to work well. All right, so that was our first workshop question associated with the first workshop. The second workshop question, what are the most pressing challenges and significant opportunities in the use of artificial intelligence, specifically to provide physical and emotional care to people in need? And this, I think, is just such a great topic because it's a very natural place to want to use AI technology. If we don't have enough caregivers and we want care to be given, automated support seems like a great way to do that. But it's a very difficult area to really do well, and to do appropriately and to do ethically. And so even though there's a need for automated support, caregiving is an intimate and human act. And so replacing human care relationships has all kinds of issues. And it can undermine our humanity in tangible ways. This is just a very tricky set of issues to try to navigate. And I think this has become, I mean, I talked to a colleague recently, or I guess I heard an interview of a colleague recently who's creating chatbots using large language models. And he says, yeah, one of my goals is that people should never be lonely again. And I'm thinking, that's a great goal, but that's a very creepy, or at least issue-laden kind of way of going about solving it. If you don't want people to be lonely anymore, to say, great, we'll just have them always talking to this fake human. That might not be a great solution, and we need to be very careful going into that. We need to go in with our eyes open. So yeah, I tried to push back on this colleague. Hopefully that message will be received. Again, great goal, but be very, very careful. We having people just talk to fake people isn't really solving that problem. All right, so fantastic. So I wanted to mention one other thing about the report, and that is, in addition to that body that I just went through with you of all these different standing questions and our reactions to it, we also wanted to do, this is an idea that Peter Stone had, is to acknowledge the previous report and talk about how our findings may have differed from it in various ways. And so the way we ended up doing that, I think, is kind of slick. So we took a copy of the 2016 report and we annotated it. So we went through, and when they said something that kind of connected with our report, we made a little hover thing. So this is an example, one of many examples that are in the annotated 2016 report. Excuse me. So the 2016 report, that's the text you see there, says, contrary to the more fantastic predictions for AI in the popular press, the study panel found no cause for concern that AI is an imminent threat to humankind. No machines with self-sustaining long-term goals and intent have been developed, nor are they likely to be developed in the near future. Instead, applications of AI with potentially profound positive impacts on our society and economy are likely to emerge. And so they said that, and we wanted to say a little bit more. So our little pop-up is, if you read through the annotated report and you just hover over that underlined part, you can see a little message from the future, right, from us, from 2021, which says, well, we remain similarly optimistic. However, society's broader worries about the future in terms of inequity, discrimination, and our ability to work together to address our most significant global challenges are reflected in concerns about the future of AI. So yeah, it's like, yes, we're positive, but like, let's temper that a little bit. All right, and so just to wrap things up, the conclusions of our report, we have a little section at the end kind of wrapping it up, and that works as a wrap up for the talk as well. AI has made remarkable progress. So there's been leaps forward in language and image processing tasks. Things that had been open problems for 50 plus years are now just commonplace and accessible to many, many people. We're seeing amazing applications in healthcare and self-driving cars. We're still far short of the field's founding aspirations. We do not have intelligent partners that are like humans. We kind of hit, I think, an inflection point in the years leading up to our report, and it has become urgent to consider downsides in addition to the being reasonably very excited about the progress that's being made, but again, tempered with this notion that there are downsides and we need to keep them in front of mind. Automating decisions at scale carries risks. People are misled, they're discriminated against, sometimes they're physically harmed. Historical data, which is how most of these systems are trained, can exacerbate biases and inequalities, right? So the fact that it's historical data when people maybe weren't being as sensitive about questions of bias and inequality, the fact that we're training our systems on them mean that they're going to now reflect and bring forward those issues and maybe even make them worse. The social sciences have become a very important part of the broader AI conversation, and the humanities as well. Ongoing engagement between these communities is essential. And this is something that I worry about sometimes, because I think sometimes we talk a little cross purposes. The AI 100 group was very much trying to bridge those gaps. And I think other groups need to be trying to do that as well. Governments, in terms of governments, we wanted to just sort of highlight to recognize the importance of AI, they need to move quickly. And I think those things are happening. They need to keep people informed. They need to support broad education about these issues. And I think they've been a little bit slow to get to that point. We really need an informed community, right, to really be able to think about these and make reasonable decisions. The AI research community also has we gave them some to-dos as well. Learn to share findings in informative and actionable ways. Writing papers in the top conferences, that's great, but let's make sure that we're getting useful information out even more broadly than that. Try to avoid hype and discuss the dangers and the benefits. Try to hit that middle ground whenever possible. Incorporate AI into community-wide systems, that it's not just the technologists sort of foisting solutions on others. And that overall, we need to make the goal to empower and not devalue people. I think a lot of us would be heartbroken if it turned out that the thing that we've spent our careers trying to develop actually is hurting people in that way, making them seem less important. We have to keep as our goal that empowering is what we want to be. We want to support people's humanity in that way. So if you haven't had a chance to look at the report, there's a link there. You can if you just type AI 100 into your favorite search engine, you should be able to find it. There's the current report, the previous report, the annotated version of the report. It's available in PDF. It's available as web pages. It's out there. All right. So let me sort of call that the end of the talk and see if we can field some questions.
All right. Thank you, Michael, for that excellent talk.
I didn't leave us enough time. I'm so sorry.
Okay, we'll try to race through this. So maybe I'll add 3 clusters of questions. So the top question in Slido is about reinforcement learning and how a few years ago, for example, AlphaGo, it was deemed to be the most promising way forward. And now it seems like all the attention is on large language models and foundation models more broadly. So is RL still a important aspect?
So
for someone who has worked on RL.
Right. I mean, I'll give you my answer, not speaking for the panel. I mean, reinforcement learning is what drew me into the field in the first place, and still the most exciting thing to me. So yes, and I would point out that ChatGPT uses a form of reinforcement learning as part of how they're making sure that the output is on task, on target, and is appropriate. Is they have lots of trained examples where people have said yes or no, and they're training towards the positives. I think, I mean, this is now me. Don't take this but my own. But I think it's great that people are using reinforcement learning in that way. But I think they're missing the really important part, which is that ultimately language is about getting things done. It's about talking to other people, influencing them, coordinating and solving problems. And that's what reinforcement learning is about. It's about having some kind of goal in mind and taking actions that reflect that larger goal. And I think that language models that are trained to just is maybe the wrong word, but that are trained specifically with the idea of sort of capturing how language exists are not about satisfying goals. They're not about actually getting anything done. And it's not until we actually bring those things together that we're going to get systems that can actually stay on task and know what it is that they're trying to do and can use language effectively.
Okay, great. Let me ask a cluster of 3 questions around more of the meta level, the composition of the report. So another top question is, who is funding the report? I guess the underlying question is there a context in which there's the contents of the report are derived? Is there a certain agenda? So that's the first point. The second question is around the diversity. So I appreciate your efforts on trying to balance making sure that there's demographic and geographic diversity, but clearly we're not there yet. The global South is still lacking in representation. So any thoughts on how to improve that? And then the third is the study panel is deliberately academic. There's no industry representation. And given that a lot of the AI advances are happening in industry, and presumably AI people from industry have a unique perspective on what is happening from kind of ground zero, what do you think of that omission? So I realized that was a lot, but we're really compressed for time.
Yeah, remind me, what was the first one? What was the topic of the first?
Who's funding the report?
Okay, all right. So you can see on the AI 100 site the history, how it came about. I do believe that the hope was to paint AI in a positive light. Diversity, global South, yes. How to do better about that? Yeah, I mean, certainly folks I have a lot of colleagues in South Africa who are trying to do great AI research and get it and make sure that it's getting noticed more globally. And I think things are shifting. I think there's more awareness of what's happening in other parts of the world, but it's a constant battle. And I think that the future panels are going to have to take that head on. As far as academic versus industry, so I don't know if you noticed, but there were several industry affiliated people on the list. Google, LinkedIn were explicitly there, and then there was other companies that are people's secondary affiliations. I do think that we had some representation from the industry folks, but they were academics in industry. So it's definitely an academic perspective, but we were informed by having people in companies on the panel. It was tricky. I'll say that. That sometimes we were saying things in the report that the representatives from the company thought were unfair to companies. And so we had to walk a line very, very carefully. By including the people on the panel, that meant that their voice was going to be part of it, but that also meant that it was going to be harder to speak in an unfiltered way. So, be careful what you wish for. But I think at the end, I do think that we said what we needed to say. We said it accurately, and we were informed by what's happening in the companies, at least what they're willing to tell us.
Okay. Unfortunately, we're really out of time. This was a fabulous talk, and everyone should go check out the AI 100. It almost feels like we need a report more often than 5 years, in the sense that so much has happened, even in the last 3 years. If you think about GPT-3 coming, that was less than 3 years ago, and ChatGPT, which is another transformative technology, that was in the last 2 months. And so we really need a report every month, Michael. So anyway, for those of you interested in getting involved, there's an open competition where you can add your voice to the conversation, where AI 100 is accepting essays for early career scholars. The winner will be invited to contribute to the next report. Visit ai100.stanford.edu for more details. And finally, we're not having a seminar next week due to other events, but join us the following week for Stanford faculty member Krish Sita on AI archaeology and archives, how data science is helping to reveal past epidemics. So hope to see all of you next time. And thanks again, Michael, for your great talk.
My pleasure. I'm happy to share slides. I'll trade them for the chat, which I didn't get to read, but it looks like there's some really interesting stuff there. So if somebody sends me the chat, I will send slides.
Okay. Thanks. See you all.